I was reading this book, A Universe from Nothing, and the book was talking about how you don't really see stars, things in the sky as they are now. You see them as they were. So, for example, if you're looking at the moon, you're seeing the moon from 1.3 seconds ago. If you're looking at the sun, it's 8 minutes and 20 seconds. So something that happens on the sun takes 8 minutes to get here. The light takes 8 minutes. And if you go further than that, if you go out to some stars, so the closest star is Proxima Centauri, and the light takes 4.2 years, 4.25 years, to get to us. So you're really seeing what that star looked like 4 years ago. Now, I thought, well, let's think about that. So the book talks about how if you created this little graphic. So it talks about, if you think about, here's the center of the universe, and here's a little piece of space, maybe there's a star there. So what I can do is, in my little graphic here, I can put the star where it is right now. So this star is sitting out here, and the light has had no time, zero time to go anywhere. So the light from that star is right here. And we are 10.9 light years away. So we're not going to see that star. If we back the star up a little bit, go into its past, go say 2 billion years ago. Now the light from the star was here 2 billion years ago, and the light from the star made it this far out, and we're still 8.9 billion years from that point, so we don't see it yet. So I can back up more, and you get the idea. When I back up to the point where that circle touches us on the little cross there. So right now, this is 5.8 billion years ago. The star was back here. This is the expansion of the universe. So, everything goes back to this little dot at the beginning of the Big Bang. And so this is 5.8 billion years ago, and the light has been going this direction for in all directions for 5.8 billion years. And so now, because we are 5.8 billion years from this spot, we see it. We see the star right there. It's here now, but we see it here. When we see it right now, we see it here. So I thought, well, that's interesting. Why don't I try and create a grid of space, little circles all over the place. And then in each grid, what I'll do is I'll do the same calculation, and I'll put a little circle here to show where this piece of space looks to us. Where does it seem to be? So I created another example of that. And so here it is. So these little circles, the little ones, are little piece of space or stars or whatever you want to think of it. And this is the center of the universe, and this is us. So let's just imagine. I don't know where we are. I'm just imagining we're over here. And so here's some little piece of space out here. So when I start this program running, it'll calculate where that piece shows up. So this little piece showed up right here. So as I do it for this grid, this nice square grid, I see each piece of space at a different age. So this one I see at 6 billion years ago. There's one at 7 billion years ago. So not only are the positions of things changed, kind of curved and squeezed, but the times are changed. We're seeing different parts of the universe at different times in their life. So I'm just going to let this run for a minute. And what we're going to end up with is it looks kind of like a spherical kind of thing. And I guess that's what you'd expect, because we're so close to the center. In this case, in this example, we're so close to the center of the universe. So I guess you get the point that this is... Let me just speed the video up here. So I clipped a little bit of the video out so that you didn't have to wait for it. So now it's almost done. It's got a few more points to finish. So the result is this sort of a spherical, looks maybe like a lens distortion, pincushion kind of thing. So I thought, well, what if I put us further out. How would that show up? Because this looks kind of uniform. I mean, distorted, but fairly nice and uniform. So why don't I do that? As soon as it finishes, it's going to finish right now. The last one. Okay. So now what if I move us out to here somewhere? Okay, and try it again. So what happens now is that things that are on the other side of the universe from us are going to appear much younger and much closer to the center of the universe, because they won't have time to get very far. And as they get just a little ways away from the universe and their light starts heading towards us, and the light takes so long to get to us that that's what we see. We see it at its very, very early age. So I guess I could mention that I'm solving this this equation with a simplex solver. That's why it bounces around. It's searching for a balance between the distance from us to this this virtual point, this point where we see it, and the age of the star, not the age of the star, the age of the universe, and that spot to match. So it's looking for the two numbers to match so that it shows the position of that piece of space at the same time as we would see it. Anyway, you can see it's building up a very, very tight pattern on the left side and a very open pattern on the right side. And see, these things over here are 11 million years ago, so it's fairly young. And things on the other side are, well, let's see, 10 million years ago, 9. It's getting, those are the oldest ones, sorry. No, wait. Yeah, that number is the distance to that point in light years, in billions of light years. Anyway, so it's almost done now. You can see this is quite a different pattern when you look at how someone out in the outskirts here, out in the suburbs, would view the distortion of the universe based on the fact that light takes time to get from wherever it starts in space out to the observer.